Hi everyone, and welcome to our video on graphing a shifted sine function. So here's our form for a shifted cosine or sine function. So shifted form, let me even put that. Shifted form. The a is still the same. So the absolute value of that will be the amplitude. The b is still the same. Now they often will put a bracket here. Okay, again, they might not, like the way that it's printed on the page. That's okay. But it really should be there. That b helps us find the period. So the period is 2 pi divided by whatever that b is. These are most important things, so that's what we graph first. And then afterwards, we use these addition and subtractions to help us. So they call the horizontal shift a phase shift. Okay, so that's a horizontal shift. And that is whatever the C value is. I usually don't like using the letter C because these letters can change. We mentioned it in a different video, but they might use like lowercase or they might change B to K. Okay, so and then they might even use like H there. And then plus, again, I'm just changing letters. Maybe they use C for that. Okay, so they can change these letters. Really just the form is what's important and knowing the vocabulary. So still knowing amplitude, period, phase shift. Okay, so the letters in math, they change those often. That's fine. Okay, so the phase shift, I usually do P dot S. And then whatever this D is, that would be a vertical shift. Now they don't call that anything special. But I usually, again, go VS for vertical shift. Okay, and then all of these letters for the cosine part are the same, just like before. We probably should put the bracket in. Okay, so, but again, they might not. All right, otherwise, in these problems, let me scroll real quick. So graphing a sine function is still doing where I'm swirling, very much like that. Graphing a cosine is very much like this one, where we use the half times 3 technique is what I used in a previous video. And then if it's shifted, we'll just have to do some arithmetic. So the very first step is really just graphing a non-shifted problem. All right, so let's get all of our letters. Notice this is in the exact form that was given right here. Okay, so I'm going to scroll. This one is not. So this one, we're going to do this in a different video, but just to point it out now. So this one requires us to rewrite first. Okay, this one doesn't. This one's good to go. Okay, so how nice. So now what we're going to do is still get all of our values. Okay, so A is 16, which is positive, and so that's great. I don't make any note of it, but I will get the amplitude. So the amplitude is 16. And then this value that is outside the parentheses of the x plus pi, but inside the bracket is the b value still. Again, matching the form. And then we can find the period. The period is always 2 pi divided by whatever that b value is. This is where I would say, well, let's just multiply both top and bottom by 3 to get rid of that denominator. So getting rid of the fraction and a fraction. And we get our period is going to be 6 pi. So that 3 and that 3 cancel. The 3 times 2 up top is 6 pi. Okay, so that's what I want to first graph. I'm going to do that right now. Okay, so without even looking at the rest of the equation, I'm going to put my graph down here so I've got lots of space to the right, and then I'm going to draw my generic sine curve. There we are. And then we'll use our amplitude. So there's 16, there's negative 16. And then the period is 6 pi, so I should have 6 pi to the right. And then now I'll do our half times 3. So half of 6 pi would be 3 pi. Half of 3 pi, again, this is where maybe putting a 1 down there can help, is multiplying the denominator by 2. So that would be 3 pi over 2 is where the peak is. And then multiply the new values numerator by 3 to get 9 pi over 2. Okay, so those are important, and let's get 0 down. So those are our 5 important x values. Those ones right there. Okay, and we mentioned it before. See how they're highlighted on other videos. And we said, oh, it makes a connection with the x and y axis of the unit circle. Okay, so if we have those are the easiest ones to work with. Okay, anyway, the reason I'm highlighting them here is because now we'll need to do some arithmetic. Okay, so we have plus pi. Okay, so that's the phase shift. Let me actually even do these in blue. Okay, so our phase shift. Now inside with the x, so notice our equation had minus, and that is the phase shift is whatever c is, if there's a minus there. Well, if it's plus, it really means do the opposite. So our phase shift would be negative pi. Okay, and this comes from the rules of transformations. So if you, going back to algebra with graphing, like, I'm going to scroll one more time. I'm doing a lot of scrolling. Like this, so here was a parabola that I used as in an example with a table. But we can see, oh, the plus 1 really means we should have gone left 1. And then that minus 2 is down 2. So that point where the vertex is negative 1 and negative 2, which we can make a connection with these values. Okay, so it looks like, oh, x, do the opposite, y, do exactly what you see. Okay, so that's what's happening here too. Okay, so our phase shift, we see, oh, x, do the opposite, so it was a plus, but make this negative. The vertical shift, we see, oh, minus 2, that should be negative 2. Okay, and so the phase shift, again, that's horizontal, so that means we will go left pi. The vertical shift is vertical, okay, so negative 2 means we will go down 2. All right, so let's break down each of these. I'm going to keep this one in the blue. Okay, so I'm going to say right here, I'm going to put a star. Let's do the phase shift first. So the phase shift is to take those highlighted values on our first graph. I'm just making a table. So 3 pi over 2, 3 pi, 9 pi over 2, and 6 pi. So there's the 5 important values. And then all we're doing is arithmetic. We are just going to do minus pi from all of these. So minus pi, minus pi, minus pi, minus pi, minus pi. Okay, sometimes the arithmetic is pretty nice. Sometimes we need to get a common denominator. But whatever it takes. Okay, so 0 minus pi, that one's nice. That's negative pi. Okay, I'm going to circle that. And then this next one, okay, that one does need a common denominator. We know there's a 1 currently down there, so we can multiply both of these by 2, and then we've got it. Okay, so 3 pi over 2 minus 2 pi over 2 would be just pi over 2. So there's our next important x value. 3 pi minus pi, that's nice, 2 pi. 3 pi minus 1 pi is 2 pi. And then the next one, okay, again, I need a common denominator. 2 pi over 2. And then simplifying, that gives us 7 pi over 2. And then the last one, that one's not too bad, 5 pi. Okay, so those are our new important x values. All right, so we've got our new important x values. Now, the next thing, vertical shift. Okay, so the phase shift I do in a table. Vertical shift I usually just show real quickly because there's only 3 numbers and they're usually nice to work with. So I am moving all of these down 2. So those 3 important y values, I'm just going to subtract 2 from. And then now I'm going to put my graph. Let's get this going. Okay, so my big graph over here is where my answer is going to be. I usually like, so I know I did the table first because that takes more of a grind. However, when I start graphing, I usually like my vertical shifts first. Okay, so if I do 16 minus 2, that would be 14. I'm going to label that about there. If I do 0 minus 2, that would be negative 2. Okay, and this, though, is super important. I'm going to do a dotted line, dotted horizontal line through negative 2, because this is considered our new x-axis. Okay, so that's going to be our focus. So the other x-axis is usually still there. I mean, you could maybe erase it if you really want to, if it's distracting, but often we keep the X and Y axes in the picture. Okay, then one more time, I need to go down 2 from -16. That would be -18. Okay, so I did these ones in the pink. Double checking, yeah, 16 minus 2, there we go. The distance from -2 to 14 vertically should be the same distance as -2 to -18. Okay, so hopefully they're drawn pretty nice. Okay, so there's the new purple information and the new Y information with the new X axis. Now I'm going to do our graphing of these X values on the new axis. New X axis. Okay, so negative pi would be to the left somewhere. Okay, so I'm going to graph that right there. So there's negative pi. And then all of these should be equidistant apart. So let's try our best again. So this should be probably about where pi halves is. And then 2 pi is about there. Okay, so still trying to make these blue ones equidistant. Next important X value is 7 pi over 2. And then the last important one is 5 pi. Okay, so this is our new setup. And then now we're just copying our curve that we sketched over to the left to match where I have my new shifted points. Okay, so where I had 0 is now where I have negative pi. And that should be right on the axis, the new axis. And so I'm going to put a big old dot there. Okay, there's that point. Let's get all of our points plotted and then we'll sketch. Okay, and then where 3 pi halves was is now where pi halves is. That's this one. But that's where the peak was on the original graph. Okay, so I'm going to just highlight again up there and put a dot. And there we go. And then just a couple more. Where 3 pi was is where now 2 pi is. Okay, so and where 3 pi was where it crossed the x-axis. So that means this point crosses this new axis. 2 more. 7 pi over 2. Or 9 pi over 2 is where 7 pi over 2 is now. And then we follow the pattern. Oh, that's where the bottom peak should be. So I'll put my little dot down there. And then the last one, where 6 pi was, is where 5 pi is now. And that's on this new axis. And then now we'll just try our best to sketch our sine curve. There we go. Okay, and like before, it might be a good idea to plot, and with these shifted ones, okay, so I think this is clean enough where we can see everything. Okay, so if yours is real nasty looking, that might be bad. Okay, so make sure things are easy to follow. Okay, so but if we wanted to, I mean, we could label all of these points. So 2 pi and -2. This one is the 7 pi halves and -18. Here is the 5 pi and -2. And then this last one was pi and -2, or I guess the first one. Okay, so there's all, so in case it gets too messy, it might be best to just, I'm going to just resketch the curve and label these X's and Y's. That might be better. That might be a good cleanup. And in math, just like English, like if you do a problem and it's messy, that's okay. I mean, just like in English class, when you're writing a draft, if it can get messy, well, you can clean it up. Okay, so we can do it on a new sheet or whatever and make it look pretty. Okay, last thing about this problem. Well, like I did on some of the ones above. Oop, it freaked out. Okay, so like this in the purple, you can always check a point. Okay, so to make sure it works well. So for instance, if we plug in, I'm going to do this one. That's an X and Y. I should get the Y value of -2. So let's see. So when I plug that in, I've got Y equals 16 sine of 1/3. And then x is 2 pi that we're plugging in, plus pi, and then minus 2. Okay, so notice this right here. I'm going to just underline, because since it's a check, we can get a little messy. This is 3 pi. Okay, so that's y equals 16th sine. Well, I'm going to do one more step here. 3 pi, and that 3 in the denominator would cancel. All of that in the big bracket simplifies to be pi. Sine of pi is 0. And then that simplifies to be negative 2. Yep, good. So it checks. And it might be worth it again to check one other point. I'm going to put a big check mark. It will work. Okay, so double check if you need to, though. If you have lots of time on a test, it's definitely worth it. Okay, so that's it. Okay, so shifted ones longer. Okay, so be patient, but still get the original non-shifted and then arithmetic. The more you do these, the faster it becomes. Okay, so try to get used to them. Okay, other than that, thanks for watching. If you have questions, please let me know.